Hello. Welcome to your technical interview. I'll be conducting your interview today. Let's start with some theoretical questions. Explain ACID properties in database transactions.
Okay, so asset properties are properties that are required for the consistent and reliable transaction in databases. And asset stands for A stands for atomicity, C consistency, I isolation, and D durability. Atomicity means that all or none. Like if a transaction is going on, it has to be complete or
I
then
notice you're looking away. Let's stay focused on the interview.
or else it will roll back. And second is consistency. C. Consistency means the transaction should be um, uh, it takes transaction from one state to other state, maintaining all the rules and defined integrated rules. And I stands for isolation, which means all transactions are independent of each other. And D is durability, which means the if the transaction is going on, if the transaction is complete, it will be committed, and it will not be deleted even if the system crashes or fails.
You did a good job explaining the acid properties. You covered all 4 key points, but there were some minor details that could be clearer. Keep up the great work. Explain the 4 pillars of object-oriented programming.
The 4 pillars of object oriented programming are first encapsulation, second abstraction, third is inheritance, and fourth is polymorphism. Encapsulation means binding all the data or method into one code that is called class, and allowing it access to users based on the requirements. And then we
Please
have
maintain focus on the screen.
then we have inheritance, which means deriving one class derives property from the other existing class, which is called parent class. Third is polymorphism, which means uh, one method is used as one method is used for other tasks too, having the same name. And last is abstraction, which means we hide the unnecessary details, which the implementation detail, and only show the details which are necessary for the users.
असल कुछ काम कर रहा है इसके लिए अरे अभी इंटरप्ट नहीं करने देगा वो गार्ड के जगह बैठे हुए अरे एग्जाम नहीं है
You did a good job covering the 4 pillars of object-oriented programming. Your explanations of encapsulation, inheritance, polymorphism, and abstraction show a solid understanding of the concepts. Keep up the good work. Great work on the theoretical questions. Now let's move to the coding section. Here's the coding problem. You can see the details on your screen. Before you start coding, please explain your approach to solving this problem. Also, feel free to ask any clarifying questions if you need to understand the requirements better. While you work through it, please plan to note the time and space complexity of your final solution as well.
Okay, so stack supports push, pop, top functions. So in push, we will push the we can make a vector, and we can push the values in it using pushback function. And for pop, first we check the condition if top is empty. If top is -1, then we will say the stack is empty, or else we will use popback function to pop the value top value. And top is simply we will display the vector value at top index. And finding the minimum, we can traverse we can use any search method for finding the minimum element.
Your approach has some issues, particularly with how you're planning to find the minimum element. Traversing the entire stack to find the minimum will not meet the O1 time complexity requirement. Additionally, your handling of the stack's empty condition could be clearer. Please go ahead and implement your solution. I notice you're looking away. Let's stay focused on the interview. Your current approach needs improvement to support retrieving the minimum element efficiently. Consider using an auxiliary stack to keep track of the minimum values as you push and pop elements. This way, you can maintain O1 time complexity for the get-min operation. Your attention seems to be drifting. Please focus on the questions. You're missing the implementation for the get-min method, which is crucial for this stack to function correctly. Consider maintaining a separate stack to track the minimum values as elements are pushed and popped. This way, you can retrieve the minimum in constant time. Please maintain focus on the screen. Please maintain focus on the screen. Please maintain focus on the screen.
Okay, sorry, I am unable to solve this get min function. Okay, I'm unable to solve this question. I want to skip this question.
Understood. Let's move on to the next problem. Your solution is incomplete. The pop method incorrectly calls vector.pop instead of stack.pop. The top method does not return the top element correctly, and the getMin method is not implemented at all. Additionally, the error handling using count statements is not ideal for a stack implementation. Thank you for completing the interview. Your responses have been recorded. Your solution is incomplete. The pop and top methods are incorrectly implemented, and the getMin method is not implemented at all. Additionally, the management of the top variable is not correctly reflecting the size of the stack. Thank you for completing the interview. Your responses have been recorded.